The year was 1983, and I was taking the Scholastic Aptitude Test, the SAT. It was springtime in Denver, Colorado, which meant it was likely snowing, as it usually does until about June. I was probably dressed in sweatpants and leg warmers because, the 80s. I remember looking forward to the SAT test because I had been studying really hard and I was super prepared. I don't remember my exact scores. I didn't do amazingly well, but I didn't do too badly. I was a very average student in high school. Clearly, I was saving all my brain power for college. But I do remember, while taking the test, that I was longing for my FX81 or even my EL240H. In case you're wondering what these letters and numbers mean, they were the names of my trusty calculators. My FX81 was a Casio battery-operated scientific calculator, one of the most excellent things in my backpack. The other two things were my Mattel electronic handheld football game and an I Heart New York coffee cup. I really wanted a Texas Instrument calculator, but my parents couldn't afford it. But I was pretty content with the FX81. It performed 30 scientific functions and factorials and held up to 6 levels of parentheses. I treasured that calculator so much. I have always saved all my calculators, but for some reason I lost this one amidst 40 years of moving. But I still have my handy EL240H, which was my very first calculator. It was a solar-powered, sharp calculator that was given to me by my brother John in 1978. Of course, being a theater student, I only pulled out my calculators when I was alone and no one could see me. I didn't want anyone to think that I was a total math nerd. Clearly, I've come out of the closet on that one. The history of math is our intellectual foundation for understanding science. Science. Beautiful, remarkable, awe-inspiring science. It's the creative foundation for our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. So, speaking of calculations, did you know that the tallest building in the world, the Burj Khalifa in Dubai, is as tall as 552 Danny DeVitos, which is as tall as 14,529 donuts. Call me crazy, but measuring things in Danny DeVitos, or even donuts, makes calculating so much fun. People have enjoyed calculating for thousands and thousands of years. There is proof of this etched in cuneiform tablets and written in papyrus. But once calculators came along, they changed the whole process of computing numbers in ways unimaginable. As I note in my book, Hypatia, The Sum of Her Life, one of the very first mathematical calculators comes from an abacus from 300 BC, known as the Salamis Tablet, which was marble etchings of dots and lines. Users made calculations by moving the pebbles between the lines. This antique tablet measured 146 centimeters by 57 centimeters by 5 centimeters. Around the same time, an abacus-like instrument called the swan pan was used in China. The swan pan held 2 decks of beads, with the upper deck holding 2 beads and the lower deck holding 5. It was a biquinary coded system, much like our decimal system. The upper deck, designed with short rods, held 2 beads. The lower deck, designed with longer rods, held 5 beads. The beads were counted by moving them towards the beam. By the 4th century of our current era, Romans used a hand abacus made with metal or bronze that had slots where the beads would sit. It wasn't nearly as advanced as the swan pan because no rods held the beads. Another common one used in the 4th century CE was the biquinary abacus. The beads comprised 2 state and 5 state components. This pocket abacus allowed the Romans to use their established system for setting a place value on fractions and decimals and extensively large numbers. For a complete description of the biquinary abacus, you can visit my website at mathsciencehistory.com, read the transcripts, and see my images of a graphically designed biquinary abacus. And quick plug, while you are there, please feel free to click on that coffee button and buy me a cup of coffee, because every cup of coffee that you buy helps to keep this podcast up and running. And I'm not kidding you, it really does help. Moving on from the abacus, in 1617, John Napier presented a manual operation for multiplication and division that included rods etched with values representing a multiplication table. It used a process called lattice multiplication, which breaks up the digits that are multiplied into tables. It's a wonderful concept that I'm going to save for a later podcast because I want to get to the good stuff about calculators. In 1623, William Schickard tried to create a manual calculating device that utilized Napier bones, but he abandoned it a year later. His notes show it worked until he tried to propagate numbers over, meaning adding 1 to 999. Upon doing so, it would jam the machine. The first mechanical calculator was presented in 1645 by Blaise Pascal, a French mathematician. It was called the Pascaline. This device was the result of 50 prototypes that he had created 3 years prior. This mechanical calculator performed addition and subtraction by turning a dial that would move gears connected to numerical wheels. One of its most valuable features was that it had a carry mechanism that would allow for adding 1 to 9 on one dial, which would carry the 1 to the next dial when the first dial would change from a 9 to a 0. They were expensive to make, which in turn made them expensive to sell. The Pascaline was sold for around 500 to 600 livres, which was quite costly in the 17th century. In today's currency, 500 to 600 livres possibly equal to around 10 to 12,000 US dollars. Pascal sold approximately 20 of these Pascalines. Gottfried Wilhelm Leibniz, a German mathematician and philosopher, made the second mechanical calculator. Leibniz presented his invention to the Royal Society in London in 1673, and he called it the step reckoner. He made only one step reckoner himself. Still, he shared his designs and ideas, inspiring others to create their own step reckoners. The step reckoner was not commercially successful and wasn't widely sold. The third mechanical calculator was made by Thomas de Colmar, a French inventor in the mid-19th century. It was called the arithmometer. De Colmar manufactured around 5,000 arithmometers during his lifetime, making it the first commercially successful mechanical calculator. The arithmometer was an improvement over the Pascaline. It was more dependable, faster, and capable of performing more complex calculations, such as multiplication and division, in addition to addition and subtraction. The arithmometer performed multiplication through a series of mechanical operations involving the movement of gears and levers. It used a system of setting dials and cranks to input the numbers to be multiplied and then mechanically processed them to produce the result. Around 5,000 arithmometers were manufactured, and they were the most sold mechanical calculator before the first digital calculator. The arithmometers were sold for around 300 to 600 francs, depending on the model and features, which was quite expensive at that time. Adjusted for inflation and considering the purchasing power, 300 to 600 francs back then would roughly equate to several thousand US dollars today. American inventor Dorfeld, in 1882, designed one of our first and most successful mechanical calculators, the comptometer. It was key-driven. He built the first prototype in 1884 using a macaroni box, skewers, staples, and rubber bands. It was patented in 1887. It was used for almost 100 years, and its development was a primary foundation for developing an electronic calculator. In 1902, our calculators became smaller, but they still used the push-button mechanism. The first one on the market was the Dalton adding machine. The original inventor was machinist Hubert Hopkins. He and his brother William Hopkins had been designing 10-key adding machines for over a decade. Hopkins gave investor James Dalton the exclusive rights to manufacture and sell this adding machine. In 1928, Remington Rand merged with Dalton and took over the selling of the models. In the early 1920s, Edith Clark, the first female electrical engineer in the United States, invented the Clark calculator while working for General Electric. It was a graphing calculator that solved line equations using hyperbolic functions and electric current, voltage, and impedance in a power transmission line. Clark was granted her patent in 1925, almost 100 years ago. Around 1948, portable calculations were made possible through the carpe calculator, which is still used today. It's a small cylinder that fits in your hand and looks like a pepper grinder. Its design was taken from the step reckoner and the arithmometer, which used values on cogs. On the carpe, there is a set of slides on the cylinder part, with each side representing a digit. The resultant counter sits at the top of the carriage. When you input a number and turn the crank, it adds another value from the slides. This cylinder allows for multiplication, division, addition, and subtraction. It was a popular device often used in the 1980s for sports car rallies. If you are interested in learning more, visit my website at mathsciencehistory.com, where I will post a number file video on how to use a carpe calculator. The first electronic calculator was invented by Texas Instruments, an American technology company in the early 1960s. It was called the Caltech. Love it, and later renamed the Pocketronic. Its key features were that it was compact, portable, and powered by batteries. It performed basic functions like addition, subtraction, multiplication, and division. It had a red light-emitting diode, an LED, which was top of the line at that time. It had memory functions which allowed the user to store numbers, and it was affordable. The only problem with it being called the Pocketronic was that it didn't fit into a pocket unless you had a huge pocket that was 8 inches deep and 4 inches wide. In 1971, Busicom marketed their LE-120A Handy. This was considered the first pocket-sized calculator, provided that you had a pocket that was 5 inches deep and 3 inches wide, or a pocket that was 3 inches deep and 5 inches wide. Either way, it's an odd-sized pocket, but definitely smaller than the Pocketronic. Regardless, these calculators pretty much only did basic mathematics. But students and engineers needed a scientific calculator capable of performing a wide range of mathematical functions, including trigonometry, logarithms, exponentials, and other advanced functions. As a result, soon after the first handheld electronic calculator, Hewlett-Packard introduced the HP 35 in 1972, the first scientific calculator. It was discontinued 3 years later. This is likely because at that point, calculators were advancing rather quickly. Within the same decade, Hewlett-Packard produced calculators that could hold 100 instructions, have continuous memory, and retain programs even after the calculator had been turned off. Texas Instruments had introduced algebraic entries for scientific notation, a pi key, and log and trig functions. The display was also getting better. Rockwell International began manufacturing calculators using liquid crystal displays, also known as LCDs. These LCDs used dynamic scattering mode, DSM, where the numbers were bright against a dark background. To create this contrast, the LCD used a filament lamp to make the numbers stand out against the dark background. Shortly after this development, calculators began to use twisted pneumatic LCDs, which placed dark numbers against a light gray background. Finally, in the 1980s, many distributors began creating and selling graphic calculators. This was 60 years after Edith Clark's first invention of a graphic calculator. For me, the 1980s were one of the greatest decades for calculators. Music? That's another story. I'll go with the 90s on that one. But for calculators, the 1980s was when the first graphing calculator was sold. In 1985, Casio introduced the FX 7000G, which could display bar graphs, line graphs, normal distribution curves, and regression lines. What a time to be alive! I'm getting my nerd on. Today, graphic calculators can plot equations and functions on a coordinate plane and handle three-dimensional graphs. With today's graphic calculators, we can visualize three-dimensional shapes and functions by rotating them, zooming in, and manipulating them. There are many of them on the market right now, including Texas Instruments TI-84CE, the HP Prime calculator with a touchscreen, and my favorite, the Casio Prism FX CG50. I like it because it calculates faster, has the largest LCD size with color graphics, seems more user-friendly for programming, has a larger storage memory, and offers a stripped-down Python environment. But I've been a devoted Casio girl since the 1990s, and buying a calculator is kind of like buying underwear. Everybody has their own personal favorite. You just have to try them on to see what you like best. As a side note, even though this podcast is about calculators, there are some fantastic software and programs that can do specialized and advanced mathematics, such as abstract algebra and symbolic manipulation. These include Sage Math, Mathematica, and Maple, all really fantastic programs. There are a multitude of calculators available today. And as one who also loves coffee, click on that coffee button at my website. As one who also loves coffee, the Caffeine Informer has the Death by Caffeine calculator so that you can know how much not to drink. The United States Geological Survey Agency has a drip calculator that can help you determine how much water a leaking faucet wastes. The Global Footprint Network has the Footprint Calculator, found at footprintcalculator.org, which can tell you how many planets it takes to support your lifestyle. At the Solar System's Collision Calculator, you can pick your favorite planet and calculate what kind of asteroid or comet you want to land on that planet and see what kind of damage it can do. Yeah, it may sound a bit twisted, but something tells me that if you're listening to this, you are part of my tribe, and you're always down for some drinking and driving on a Friday night with the Collision Calculator. That link can be found on my website at mathsciencehistory.com. If you want to discover even more calculators, you have to visit the Omni Calculator, which was designed by physicist Steve Wooding at omnicalculator.com. Here you can find over 3,000 calculators for a variety of needs, including chemistry, physics, food, health, and even weird units. Suppose you're interested in knowing how many Danny DeVitos it takes to get from your home to Booger Hole, West Virginia, or how many donuts it takes to cover the moon's circumference. Well, the Omni Calculator also has a weird units converter, which can help you calculate various measurements, including Hollywood signs, high heels, Eiffel Towers, slices of bread, or even lightsabers. No doubt, calculators are genuinely one of the greatest inventions ever made. We are making advancements in science and mathematics alongside the product that is also making advancements in science and mathematics. It's fun when you think about it that way. Calculators have made it an exciting time to study mathematics, physics, chemistry, and any endeavor in science. And even if the analysis gets tough, remember, you can always count on your calculator. I'm loving this way too much. I'm really getting my nerd on right now, and I don't care. I really love calculators. I really do. And if I have any calculator addicts out there, please feel free to find me on social media or message me at mathsciencehistory.com and share your favorite calculator with me, because I'd love to know what you use too. I'm always down for trying a new calculator. So thanks for listening to Math Science History. Until next time, carpe diem. Thank you for joining me at Math Science History. Please remember to subscribe to the show. Also, if you could please leave a rating or a review, it would be really appreciated, because those ratings and reviews really do help to increase my listenership, which help to get me more sponsors which help me keep the podcast up and running. If you want to learn more about the history of math and science, please visit me at mathsciencehistory.com. If you like what you're listening to, and if you like what you're reading, please feel free to click on that coffee button and buy me a cup of coffee. Every cup of coffee that you buy helps me pay for the expenses that go into making this podcast. Also, if you're interested in leaving me a comment or chatting with me, you can always find me on your preferred social media platform, including X, Instagram, Facebook, LinkedIn, Goodreads, TikTok, Threads, etc., etc., etc. Just go to Google and search for Gabrielle Burchak. You can find me everywhere. Until next time, carpe diem.